Hello Year 10s. Today we're going to look at graphing systems of linear inequalities. That means when you have more than one linear inequality, how do you represent more than one Cartesian plane, and how do you end up with what's called a feasible region, or a region of possible solutions that satisfies many different conditions for x and y. Alright, so our example today, we're going to look at these three equations, and the process we follow is very similar to graphing a single linear inequality. A single linear inequality, however, we just shade the region required. Here, one of the steps will be shading the region not required. And I'll explain why when we get to it. Alright, so, graphing a system of linear inequalities, let's take the first one. I know that that goes through the y-intercept of, the y-intercept of 4, and then for one back it drops 3. One back drops 3. And I know that because it's less than or equal to, it's a solid line. Poorly drawn, but you get the idea. Then, test point to figure out which side we'd like. Now, test point, 0, 0 is the easiest. If that's 0, that goes also 0. 0 is indeed less than or equal to 4. Therefore, the region we want, because it satisfies the condition, is this bit. But remember, we're not going to highlight the bit we want. Here we're just going to highlight the bit we don't want and move on to the next equation. Here. I'll do this one in green. Y is greater than a half x minus 4. Means it goes through 4. For every one across, it goes half up. One across, half up, one across, half up. And because it's strictly greater than, I'm going to do a dashed line. Now, test point, once again, I'll put in 0, 0. That would go, that becomes 0. This is saying 0 is greater than minus 4, which is true. So we would normally want the above the line. Here we're going to shade the bit we don't want. We don't want below the line. Now, y is strictly less than minus 2x. Minus 2x goes through the origin. And I'll do this one in, what other colours do I have? Red goes through the origin. Then for every one across goes down 2. One across, down 2, etc. One back, up 2. And once again is dashed. Now, we can't use the origin as a test point because we've gone through the origin. So instead I'm going to choose the point here, 1, 0, which will give us the equation y is less than minus 2x. Sub in 1, 0. 0 is less than minus 2 lots of 1. 0 is less than minus 2. Not true. If it's not true, it means we don't want it. So the test point is in the region we don't want, and for now we're shading the regions we don't want. So I don't want this region. Now, what you may notice is that those three inequalities have enclosed a space. Because remember, we're shading the region we don't want. That means blank regions are ones we do want. The only blank region left is this one in here in purple. That means that for every point inside that little triangle, it would satisfy all three inequalities. So for example, if I took the point here, minus 1, minus 2, and sub that into all three inequalities, it would satisfy all three inequalities. Everywhere within that triangle contains feasible solutions to all three of those inequalities. This is what was called the feasible region. All our solutions belong in there. And in there are infinite number of points. And the reason we have been shading the regions we don't want throughout this problem is because if we shade the regions we do want, that feasible region would be coloured in 3 times over. And it starts looking very messy. So what we do here is we colour in the regions we don't want, and whatever's left is our feasible region. Alright, once again, we need to write a key. So we would just draw a blank space and say that is region required. Right. Now, that is how to plot systems of linear inequalities. And we'll go into how to use this skill in more applied problems in the next video. Thank you very much.